This video discusses your quadratic transformation worksheet. You are to answer the following questions based on the notes that we took the day before in class. So the first question, just to review, is to write the vertex form of a quadratic equation. Remember that the vertex form of a quadratic equation is given by the following equation. F of x is equal to a times x minus h quantity squared plus k. You are supposed to, in step 2, question 2 here, answer the following question. What does changing the a variable do to the graph of a quadratic? You are supposed to tell me, in general, what does the a do. So if the a is positive or negative, how does it open, up or down? What effect does the a have on the narrowness or the wideness of the graph? Those are the types of questions I'm looking for. In step 3 here, you have to be specific and name 3 ways, there are really 4, that a parabola will change with different types of a. What I am looking for there are the following. What if a is positive? So if a is positive, a is greater than 0. What happens? What if a is negative? A is less than 0. What happens? What if a is greater than 1? What happens to the graph? And finally, what if a is between 0 and 1? What happens to the graph? You are to continue answering these questions, and most of these answers should be found in your notes that we took in class the day before. For example, we discussed what happens to the graph when we change the k variable. And you have to make a conclusion about the variables of h and k together. What I'm looking for there is basically the ordered pair hk will tell you the what of the parabola. For this page of the worksheet, you're supposed to write the quadratic equation for each of the following graphs in vertex form. So for this problem number 1, remember that my vertex form is f of x equals a times x minus h quantity squared plus k. So the first thing I'm going to do is I'm going to identify the vertex. The vertex of my graph is sitting right here at 2, 0. So my vertex is 2, 0. So if my vertex is h, k, then that means that h in this problem is 2 and k is 0. So my equation becomes f of x equals a times x minus 2 quantity squared plus 0. So then my next step is to identify what my a is. Remember that in my parent graph, which is y equals x squared, my basic count was 1, 1, 2, 4, with my vertex right here at 0, 0. So if this graph is a normal width graph, I should be able to count from my vertex, and I should be able to count right 1, up 1, and land on my graph. Then go back to my vertex and count right 2, and I should be able to count up 1, 2, 3, 4, and land on my graph. So this particular problem is a normal width graph. So here my a is 1. So my equation is f of x equals 1 times x minus 2 quantity squared plus 0. Alright, so let's look at the second one on here. I'm going to blow this one up here so it's a little bit easier to see. Now it's a little bit hard to read on this graph because it's a little bit distorted when we blow it up that big, but we'll see what we can do here. Looking at this graph and identifying the vertex, your vertex here is at the origin, 0, 0. So that means that h is 0 and k is 0. Remember, your vertex is h, comma, k. Now, also to determine the a value in this graph, I need to start at my vertex, and I'm going to look to see if it is my normal basic count, remember, which is 1, 1, 2, 4. So if I look at this graph and I count from my vertex and I count right 1, but I count up 1, I do not land on my graph. It's close, but I don't really land on my graph. I have to count up 2 to land on my graph. So that count was 1, 2. Then if I go to my vertex, back to my vertex, and I count right 2, I count up 1, 2, 3, 4, 5, 6, 7, 8, until I land on my graph. So that count was 2, 8. If I compare this particular problem here, this count here, to my parent graph, notice that it basically took my parent count and multiplied the vertical count by 2. 1 times 2 is 2, 4 times 2 is 8. So this makes my a value in this problem 2. So my basic equation would be f of x equals a times x minus h quantity squared plus k. And subbing in here, I end up with f of x equals 2 times x minus 0 quantity squared plus 0, or finally f of x equals 2x squared. Okay, for problem 14, what we're going to do is we're actually going to graph the following function. F of x equals x minus 3 quantity squared plus 4. So the first thing I'm going to do is I'm going to actually find my vertex. So remember, my vertex is hk. So in this case, my vertex is 3, comma 4. Remember that the one inside the parentheses, the h, switches signs. So that's why this negative 3 became a positive 3. So the first thing I'm going to do is I'm going to plot my vertex. So I'm going to go from the origin, I'm going to go right 3, and I'm going to go up 1, 2, 3, 4, and I'm going to put my vertex right here. Now, if this is my a value here, in this case is 1, so what I'm going to do, this will be a normal width graph. So my parent function, y equals x squared, remember, has the count 1, 1, 2, 4. So from my vertex, I am going to count right 1, up 1, and I'm going to put a dot. Then I'm going to go back to my vertex, and this time I am going to count right 2, and I'm going to count up 1, 2, 3, 4, and I'll put a dot. And then I'm going to take these points and I'm going to reflect them over. So when I reflect them, this point here will go right here, and this point here will go over right here, and my parabola now becomes this parabola right here. Notice that it is a normal width parabola, a is 1, and the vertex is at 3, 4. Alright, so let's try the next one here. Okay, problem 16 says f of x equals 1/2 times, in parentheses, x plus 2 quantity squared plus 3. So the first thing I'm going to do is I'm going to identify the vertex hk. H becomes negative 2 and k is 3. Again, the h switches signs. So the one inside the parentheses switches signs. Now, remember that my a value here is 1/2. So this should tell you that my parabola is wide. Okay? So what I'm going to do is I'm going to first plot the vertex -2, 3. So I'm going to go left 2, and I'm going to go up 1, 2, 3, and put a dot. That will be my vertex. So I'm going to label it V. Okay. In my parent function x and y equals x squared here, my normal count was 1, 1, 2, 4. So to do this, what I'm going to do is I'm going to take my normal count and I'm going to multiply it by my a. So I'm going to multiply both of these vertical counts by 1/2. Whoops, sorry, let's read that a little bit better here. Multiply by 1/2. And I'm going to take 4 times 1/2. So 1 times 1/2 is 1/2, and 4 times 1/2 is 2. So what I'm going to do when I do my count here is normally I would go from my vertex, I would normally go right 1, up 1. But this time what I'm going to do is I'm going to go right 1, and I'm only going to go up 1/2. So I'm going to go halfway in this square, the best I can. Then what I'm going to do is I'm going to go back to my vertex, and this time I am going to go right 2, but I'm going to go up 2 instead of up 4. And then I need to reflect these 2 points here. So this red point is going to get reflected right over here, and this point here is going to get reflected right over here. And notice that my parabola is now looking like this. And so it's a wider parabola than what I'm used to drawing. So this is the graph of y equals 1/2 parentheses x plus 2 quantity squared plus 3.